So welcome to Chapter 7. We're going to spend some time talking now about sampling and sampling distributions and really getting into some more of the research side of the statistics. So remember, we've already talked about this. A population is all of the items of interest. So, if it's voters, as we're going to talk about in a minute, then it's all the people that are eligible and registered to vote. If we're talking about students, then it's all the students either in the US or the world or maybe in Texas, depending on what our population is. Most of the times the population parameters, such as the mean and the standard deviation, are unknown. Therefore, we have to take a sample of the population and a subset of the population, and we use our statistical methods that we've learned and we are continuing to learn to draw deductions about the population. So we'll run our statistics on our sample and then we'll make conclusions or draw inferences that we can apply to the population. But in order to draw good conclusions, to draw good inferences, we have to have a good sample. So there's no way that we're ever going to get a perfect sample, but there are some ways that are better than others at drawing that sample. So a bias happens when our sample is set up, obviously unintentionally, but is set up to either ignore a particular subset of the population or to sample or over question to favor, I should say, a particular subset of the population. And so what happens then is that our sample isn't truly representative of the population, and then some of the inferences that we draw are not correct. So a classic example, and there's a lot in your book if you read through, was in 1936. The Literary Digest magazine predicted a landslide victory for Alf Landon over Franklin D. Roosevelt with only a 1% margin of error. Now, turns out that they were wrong. FDR won that election by a large majority. So let's look at what Literary Digest did, and maybe we can find out some things that we want to make sure we don't do when we're sampling. First of all, Literary Digest drew their sample from their own subscriber list. So instead of drawing it from voter registration rolls or everyone that is eligible and registered to vote in the United States in 1936, they just sampled or questioned their subscribers. Now, their subscribers aren't necessarily a representative sample of the entire population in 1936. Remember, 1936 is in the middle of the Great Depression. So only people who were very wealthy could afford to even subscribe to a Literary Digest magazine. I mean, that's a frivolity, that's an extra indulgence that many families could not afford. So just because they subscribed to Literary Digest doesn't mean that means that they were automatically have a bias in there. Also, again, people that subscribed to Literary Digest, at least in 1936, were again more educated, relatively more educated than people who didn't. I mean, this would be like saying, okay, we're going to only sample people who subscribe to the Wall Street Journal. Again, the Wall Street Journal population tends to have more education level than, your standard magazine. So again, we're looking at a very specific subset of the entire population. Only those people who tend to be more educated and could afford a magazine in 1936, a magazine subscription in 1936, which again left out a lot of people in the United States. So obviously they had some bad sampling there. So selection bias, which is what Literary Digest did, is you systematically underrepresent certain groups from the sample. So again, Literary Digest didn't sample people that were low income voters that didn't have enough money to afford a magazine subscription. Again, there's a underrepresentation bias because from an education standpoint as well. Again, they're only sampling those that are more educated as well. There's also a non-response bias. So non-response bias happens when you send out a bunch of whether they're postcards or in today's day and age, it's going to be emails. You send this out asking people to take this survey. Of course, a large majority of people are just going to ignore that. They're going to delete that email. They're going to ignore that postcard that they got in the mail. And so they're not going to respond. Now, if we look here, Literary Digest had a 24% response rate, which I like how it says only had a 24% response rate. 24% is actually pretty good as far as a sample goes. If you get 24% of respondents to respond, that's actually pretty good in real life. But again, there's a non-response bias in that even if we were doing this today and we send an email to every registered voter in the United States, only those who are really interested in politics, who are really invested in the population, are probably going to take the time to respond. The rest of us are going to say, ugh, whatever, and delete that. We're not going to waste our time responding on it. It takes time to respond to these surveys. Usually they're several questions long. We're just not going to waste our time with it. And so again, you get a response only from people who want to respond, which that in and of itself represents a bias. You don't really get the response of the uninterested voter or the voter who's not highly motivated to respond to these requests, these survey requests. There's also what we call a social desirability bias. So it can be, again, socially acceptable or socially desirable to respond a certain way to a survey, even though maybe that's not how you would have responded in real life. So again, we see this a lot with polling data, especially on election day, and there's news cameras standing outside the polling place and they're interviewing people as they come out of the polling place, and they may say, do you want to tell us who you voted for? Well, let's say that you live in a very, very red area, or you could live in a very, very blue area, right? You may be tempted to respond the way that you think the majority of your peers are voting, even though that may not be privately how you voted. Again, this also happens with any sort of, not just elections, but with anything like this. When we're doing a polling like this, we may see responses based on how people think their neighbors are going to respond, especially if we have some inkling or some kind of fear that maybe responses of the survey won't be kept entirely private. So again, I'll give you a personal example. I used to work for an organization, not TCC, but I worked for a different organization, and they decided they were going to take an employee satisfaction poll. And they sent this poll out to us, and we were supposed to click all these answers based on how we felt about our job and all of that. And I just kind of had a sneaking suspicion. I don't have any evidence. I still to this day don't have any evidence that this was going on, but I had a sort of sneaking suspicion that my answers wouldn't be truly private, I guess is the word that I'm trying to come up with, that somehow management and maybe people who are smarter at computers than me were going to get in there and see how I felt about my job and my boss and that sort of thing. And I worked for a manager at that point who was sort of vindictive, and if they thought that you didn't like them or you weren't on board with the way that they were doing things, which I have to say I thought was a little questionable at times, not just in effectiveness but in morally questionable at times, then you were likely to be fired. This manager didn't like being questioned or challenged or anything like that. And so when that survey came to me, I thought, there is no way in the world I'm going to tell them how I really feel, because I need this job. I cannot afford to get laid off. I cannot afford to have my manager mad at me. So I'm going to tell them whatever they want to hear. So I filled that out like I was the happiest employee there ever was, while of course the whole time I was secretly and had been secretly job hunting on the side. So this is something that happens, that comes up, and so we need to be careful and take that into consideration. Again, online surveys conducted by a third party tend to mitigate this bias. You know, if the survey is conducted by a third party, then I may feel less like they're going to reveal my information to my employee. Maybe if it's an online survey and I'm not having to hand write it, where, oh, now they're going to be able to read my handwriting and tell that it's me, that sort of thing helps to mitigate this bias. So some sampling methods that we should take into consideration. We want what we call a random sample. Okay, so random sample means that we are not intentionally targeting or intentionally leaving out any particular subset or subgroup of the population. Now, as we've talked about, most of our statistical methods presume or assume that we are using random sampling, that we've just randomly grabbed, 40 tweens as they were approaching the ski resort and said, hey, can we ask you some questions? But we do need to take some steps to try to ensure that our sample is truly random. So one of the things that we can do is we can divide the population into subgroups of what I like to call, what they call strata. Okay, so the strata is mutually exclusive, meaning you can't be in more than one strata, and they are collectively exhaustive, which means they would include all the people in the population. So maybe we would break them down by age. So if we're going back to the election, maybe we're breaking them down by 18 to 25, 25 to 35, 36 to 45, 46 to 55, whatever, so that we are capturing all of the potential voters here. Maybe we break them down by geographic location, so all of the voters that are located in Texas versus all of them that are located in Oklahoma or whatever we're doing. And so we can then randomly select observations from each of the strata. So then we can, again, if we've got all of our observations that are 18 to 25, we're going to randomly select a certain number there, and then we'll randomly select a certain number from the next age group, 26 to 35, and so on and so forth. This will at least help to ensure that we have a random sample from each of the strata, that we're not intentionally, we haven't over surveyed or sampled maybe an older population that might subscribe to Literary Digest versus a younger population who doesn't subscribe to that magazine or something like that. Another sampling method is cluster sampling, and this is where, again, we're going to divide our population into a mutually exclusive and collectively exhaustive groups. We call these clusters, and then we'll randomly select an entire cluster. So an example of this is maybe we break them down by geographic location, and maybe we break them down by, counties in Texas, and then we'll randomly select some counties to sample everybody in that county. So we need to take care to make sure that all of our counties aren't, in North Texas. We want some counties from the Panhandle and some from East Texas and some from West Texas and Central and South and Southwest and Southeast. We also want to make sure that our clusters that we're sampling are, some metropolis, city, some suburbs, some rural areas, those sorts of things. But we can, instead of sending it maybe to everybody, we can say, all right, we're going to sample Tarrant County, and then we're going to sample I don't know any other counties around here, but a county in North Texas, a county in the Panhandle, and maybe a county or two in West Texas. And so we can kind of select that way. This is cheaper than some other sampling methods. It is a little bit less precise, but it is cheaper. So again, I know stratified and cluster sampling can sound the same, but they're not exactly. So stratified sampling means you're sampling from each of the strata. So meaning if we're going back to our voting age blocks, maybe we're going to sample, 200 people from the 18 to 25 range, and then 200 people from 26 to 35, and 200 people from 36 to 45, all the way up. Cluster sampling says I'm just going to randomly select certain clusters to survey. And this is done a lot with stores and restaurants and franchises that maybe they're going to test a new product, maybe they're going to test a new menu item. And so instead of putting it in all stores, they're going to randomly select a couple of stores and they'll put it there and then test it to see how it does. Now in Excel, we can generate a random sample very easily. We use the formula rand between, and then we just put our lowest number and our highest number, and then we just run the formula. So in just a minute, we're going to jump over to Excel and practice that for just a moment. So here we are in our Chapter 7 Excel spreadsheet, so make sure that you've opened that. Now, we don't need a particular page for this example, so I've just opened up a new sheet down at the bottom. You just press this little button here and it'll open up a new sheet for you. And then we're going to go ahead and enter our random sampling in. So let me give you an example of the way that I use this exact function in real life. So when I give test in classroom, in a classroom setting, on test day, I randomly reorganize where you sit. So usually students come to class, and even though we don't have an assigned seating chart, students like to sit in the same place every day. But on test day, I want to kind of shake things up a little bit. So everybody in the grade book, I'll just download the grade book to Excel, and everybody's assigned a number based on your your last name. So usually 1 to 30, right? And so then I will just say equal rand between, and the bottom number is going to be 1, and the top number is, well, let's say there's 30 if there's 30 people in the class. So then the first one is 27, so I'll look and see who person number 27 is. And by the way, you're going to get test number 1, and you're going to sit in seat number 1. And then I just drag this all the way down, and here we go. Now, the problem with this is that every time I drag it down, it creates a new random number between 1 and 30. So you'll notice there's some repetition here. See, I have number 9 and number 9 and number 9. Well, student number 9 on my roster doesn't have to take 3 tests, right? So we'll need to do this a few extra times so that we can then delete the duplicates, and I can make sure that everybody has a test and you're assigned a specific seat in my seating chart in the seating order, and then this is how you come in. So, all right, so we will pick up with 7.2 on the next video.